AI in games. You still believe in that? You think that LLM that we're using, for example, in ChatGPT and Gemini and others, artificial intelligence, work the same way in games? You think that, oh, I have been playing for so long time for Grand Theft Auto and it is using the same AI that we're using with text? Not. What you're thinking about. Let's discover step by step how does it work and what is idea of game AI, because it's different one. It's not the one that you're using with your games, with your for example, once more time, ChatGPT or any other stuff. It not works in this way, because AI for game, it's a bunch of rules that our characters or NPC non-player characters are taking. So basically, it's not what you're thinking about. Okay, let's start from the very beginning. AI in games is quite a long time with us. For example, the new models of ChatGPT or Gemini, or in general that one that have been popular, they're not so long time ago have been created. But artificial intelligence for games, it's quite a long time with us. So you're thinking that they're using the same one? Not, completely not. And one more thing, they won't use these models that we are using. You can be wondered why. The thing is, in optimization. So, when games was created, there was a lot of requests to make some enemies that will work against you. So this is an idea of the game. So always you have enemies, you have your main character, and you should win something. So how these enemies should work? They should, for example, attack you, or for example, catch you, or something like that. So an idea here was just that these enemies should do some bunch of rules to win. That's all. Nothing too complicated. So, basically, it's just a couple of rules that Call of Duty, on the one more time, Grand Theft Auto are using, because AI in games quite long time here. So we have just some algorithms and other stuff that help us to work in such a way. So basically, for example, when we have sims or any other non-player characters that are doing something, basically it's programmed to do something. They have a bunch of stuff that they should do, and it's written what they should do, where they should go, what they should take, what they should do, for example, when you are making aggression on them. So it's just a bunch of rules, and this is real AI here. Why it's in this way? Because firstly, we should control that. For example, you have wall. You're telling your non-player character that you can't go through this wall. But if we have LLM, we're not controlling that. And at one moment, it just can think, oh, I can go through this wall. Or I can be unbeatable and just beat your main character every time, or even won't be able to restart the game. Everything can be in such a way. So that's main idea, that we should control that. We should say, you should go in this way, you should go in that way. That's how it works. And basically, when we're working, for example, with sims, they have long-term and short-term goals. And to reach these goals, they're doing specific things that are pre-written in the program. That creates this idea of artificial intelligence, that these characters are doing that thing and others are doing that way, and that's not just the random stuff. So they're pre-rendered, presets that are working this way, and that's why the AI logic is much more harder in games, because you should really pre-write that, it should work stably, and that's why creating such AI in games is harder, but it's more stable than in LLM. But that's a problem that in general can be solved. This controllable of artificial intelligent large language model. The biggest problem here, it is that LLM should be held on really powerful computers that are not right now for each of household members that are playing games or phones. Yes, they can help AI, not so great one, like some limitations of that, but if you want to use that for your characters, can you imagine how many characters could you have? You can have 100 of them. Can you imagine how much request it will be for your computer or phone? I'm not even think that powerful servers can help such thing. So that's why we should use game AI presets. Some things that I will tell you a little bit later. How does it work? What should we use for solving that or another problem? So basically, that's all, and that's all important. What you should know. Also, there is problem with latency. So if you will, for example, send requests, for example, to OpenAI, you'll have problem here because your characters should respond instantly. They shouldn't wait. For example, you're beating and they're just waiting. What? Not. It shouldn't be done in this way. So that's how it works. And you see that everyone, all of the games are using that. Yes, some games can use a real language model just to make requests. For example, you have a chat. That's okay, of course, that can be used. But basically, games are created differently here. So that's what you should discover about AI in the games. But what we should use, or in general, what we can use. So we have a bunch of ideas what we can do here, and we can use behavior trees, for example, navigation mesh. We can use once more time how is it called, state machine, paths finding. So it's just some algorithm systems that helps to work with one of the ideas of your characters. So like find the path somewhere, or for example, state machine that we'll be using today. So you'll understand how this AI really works. I hope that you understand right now how it should be working, and let's continue with our game. So what do we see here? We see here Unity app, a quite easy example of how real AI works here. So firstly, what we should do? We're clicking on plus button, we're creating 3D objects, and we're using plane. Plane will make this plane for us. So where all of our characters will be. Oh, a sec. Yeah, here's it. So here will be our enemy and our main player. Let's go to our enemy. Enemy is just a sphere. One sec, I would like to find it. Yeah, here's this sphere. So this will be our enemy. I just put it to 5, 1, 5. And player, that will be our sphere, will be on 0, 1, 0. That's all. Nothing too hard here. And to create such example of the game, we just should make a couple of stuff so we'll be able to work that, and you'll see. So first thing, we're taking rigid body. How you can take that? You're just clicking component, rigid body, and you're adding that. One sec, let's go back here. Rigid body for your player and for your enemy. Why we should use that? So we'll be able to be on the plane, and we won't be able, like, we're adding just physics. That's all, like simple physics that can work in our case. But here what we should do, nothing in player rigid body, but for enemy. As enemy can work separately for us, so we should just freeze some things here, to not to go up and down, and just to freeze rotation, because it will be important for us to this AI to work not unexpected in our case. So you can just experiment and unfreeze them to discover how it will work, but that's basically an idea how it should be done. Then after we have created that, we should add possibility for our sphere to move. That's pretty all. So you're going to edit on the top bar of your application. You have here File, Assets, Game Objects. You go into Edit. You're clicking on Project Settings. That's important here. And then we're going to Player. In Player, we're going to Other Settings. And here, in Other Settings, you can see, we're going to Active Input Handling. Why we're using news, like default one is input system package new one, but it's not always work with your, for example, elder laptops or something like that. So you can use, like if you will have problems with input, you can activate both of them. If you won't have any problems, you just leave with new system package management. That will be okay. So like it's automatically understand VASD, arrows, all such things. Okay, that's what we have here. That's really nearly all. Nothing too hard here. So we can go further. We're going to our assets. In our assets, we are creating a folder that we'll call scripts. Like we already have this, so this one I can delete. Yep. Let's go to the scripts. And here we should just click right button, create. We're going to scripts, empty C# script. And we should create firstly 2 of them that we'll call AI enemy and player movement. Yeah, player movement. One sec, let's click on that. You can see player movement. So you can just click open or double click that, and in any case you'll be open with your, for example, Visual Studio Code in my case. So you have a structure here, assets, scripts, our folder. Okay, it also can give an idea to install Unity extension. Do that if you want to. So what we'll have in our AI, enemy, and player movement. So enemy AI. We see here that first we'll have just a simple public class with nothing more, so just using Unity engine, and all of that will be just empty, of course, because you just should write it by yourself. So simple AI here is just to track your sphere. For example, we're going somewhere, it is going somewhere, or just it's going for us non-stoppable. That's an idea, but that's one of the most easy ones. So there is nothing hard here. And one more time, mostly you won't use any OpenAI credentials API to work with your AI in games. You will be just using some algorithms here. So for example, here we're just using mono behavior. We're taking transform for our player transform, and we're taking the speed move that in general we'll be able to change if you would like to. This is like default one for right now. Wait start. What we'll be doing? First, we'll be finding a player with stack player, and I forgot about this moment. Let's go back here. So basically, when you're, for example, in player, you just click tag player. You're just clicking add the tag. You see here list is empty. You're clicking plus, and you're writing player save. That's all. Like, and then you'll just have the same screen. List is empty. Like it will be the same. You're clicking on player, and you'll be able to take the player tag. Why we should do that? Because our AI enemy should understand which object it should find. And with text, it will be much easier than just to write its ID or something like that. So we're taking game object, player object. We're finding that by tag for ID, and if there is nothing of that, so like if it's not null, so we're just telling that player transform will be player object transform. So what does it mean? That we'll be just taking position of our player, so it will be able to grant to that. That's pretty all. So you'll be just finding over time the easiest way to go to that direction. That's pretty all. And if we don't have, so we just writing that player object not found, make sure it has the player tag. So in our debug logger. Then update. It's like every frame that we'll be using on. So if our player is not null, because if it's null, we'll have problems in our loggers, so we shouldn't have that right now. And we're using move towards. So it will just update every frame how we can go to our object. So we are using transform position. Why we are using transform position? So we'll be just transforming our current element. We'll transform in positions that have our enemy to vector 3. Why vector 3? Because we have x, y, z. So it means that we'll be working with our 3D graphics and how our enemy can go in any direction. And move towards, it means that we're just saying he should be here, he has these coordinates, and every frame it will update to go to that position. So basically what's good in your engines for gaming, that a lot of the things they're doing by themselves, like all the algorithms are working good, and that's how it should work. So we're just telling that move forward. Then where we should go, we have our starting position, transform position, and we have our player transform position. So we're just taking player transform, taking this position. Then how fast we should move. That's all. That's pretty all the things that we should understand here. We're taking moving speed, and then we're increasing that by time, delta time. So it will be smooth here. So this multiply will make the smooth framing. Like you'll see, it won't be like one. It won't be like stepping. It will be rolling. It won't be like freezing frames. 1, 2, 3, 4. It won't be jumping. It will be going smooth. So this time delta will make that. That's an idea. And let's discover how that does work here. So it will go from this position to our enemy in that direction. And how we can take this script to our enemy. We're clicking on enemy, and then we're just moving this script here. You can see that I already have, for example, advanced will disable, and we'll be clicking on enemy AI script. So you're just putting it here or down. It doesn't matter where you will put it. Just put it in this place. And that's all. Nothing more. Let's go for our player. So it will go to our player movement. We'll see also mono behavior, because only for this player. We have move speed. Basically it should be more than enemy, because if it will be the same, enemy every time will be mostly taking us, because it's non-stop, and we human, we're mostly stopping to understand where it should go next. So move speed 5 we'll be using for our player. Then we're taking rigid body, and let's discover what it will help us. So we're taking our rigid body component here. This is more, like you see, this is a more effective approach than calling get component every time. So that's why we're just taking our component from the start. We're taking our variable RB that we'll be also using here. Once more time, void, it means that it doesn't return us anything. So it's just a simple C# idea. And let's go further. So what we have? We have here float input get axis, vertical and horizontal. And let's little bit talk about that, so we can also discover it here. So get input from the keyboard. Horizontal and vertical are Unity's default input axis corresponding to AD or left right arrows and VS or up down arrows. So that can help you not just taking these arrows or taking this keyboard separately. It just takes it by default, because it's really default things that are mostly using, and that's why Unity are writing that for such easy ways, so you'll be able to easier create games, and it won't be so bad, and it will have better algorithms just at Unity engine. That's pretty all. Let's go further. So we're just taking input that our keyboard will be doing, and get access. You can understand that this is a method that we're taking, and it automatically understands that we're taking W or S or AD or arrows or something like that. So that's move horizontal, move vertical. Then we're taking new variable that we'll call movement. What it will be? We're creating new vector 3 once more time is for our x, y, and z variables. We're taking move horizontal. We're not changing any our y. We're not changing that. It can be changed mostly by space, but in our case it won't be the such way. Move vertical, and that's in this way we're working. That's all. Like, it just takes in data that we're taking and creating a new vector, and it works. So then we're just taking our rigid body, linear velocity, and that's how we'll be using it with it. Sorry, just camera stopped to recording, so we should re-record it. So yeah, as I told, so we have rigid body here, linear velocity. So, and we're taking movement that will be multiplied for move speed, and it will take us more smooth way how we can move with our character, and it will be going frame by frame. It will be really easier, smoother, and that's how we can do that. And also we're using linear velocity, so it can just help us to go to the xy that we're taking based on our movement that we're taking on the 27th line. And let's discover how it will work here. So that's what we have. We're just going to, like, that's files that we have. We go to enemy, and just taking this one, putting it anywhere here. So you just should see this blue line. It should be after, above any other component. So you just should find one, for example, after transform before cube, and you're just putting it such way. So you'll see here these files. For example, in our case, we should use not advanced for just simple purpose enemy AI. Have move speed that we can change. Then we're going to our player, and we're making the same one here. We're just putting this player. We'll see here move speed 5. Let's discover how it will be working on. So we're just clicking run, and we'll see that will be our cube is going to us, and we'll see physics like we're going down on our plane, and yeah, we're here, and right now we can go, and this cube will be trying to take us to find us, and yeah, and right now we're out of out of plane. Okay, that's how it works for us. Let's stop that, and let's go further for our advanced mode, because that one was pretty basic variant of how we can work with that. But right now we'll be using much more complicated way. Not so much, but a little bit. So let's go to our AI advanced one. So what we have see here. Mode behavior, also because it will be for our enemy. Taking player transform. So it will be our player that will be just storing our player here in this variable. Then we have an idea of machine states that we have some range. After that we'll be using one or another condition. So basically, when, for example, you have been playing and your enemy was running to you, and you just have running faster, and at one moment your enemy just was standing. That's all what he has been doing. That's called machine states, and it gives you the range of how your enemy will react when you are closer to this non-player character. So basically, in our case, our observe or just sight range will be 10f, but our attack range will be 2f. Any other, so between 2 and 10, will be just running to it will be just running to you. And if you have also move speed, like the same one that enemy had here, and also we have states. So in our case it will be ideally chase and attack. Ideal will be for our running, chase, and attack will be for us two other states. Basic one, current state, will be running too. So that will be like the basic one. And for starting, we'll be taking your player as we have been doing it here. So we just for taking the tag name, that's pretty all. Yeah, without any debugging in console. So then we're taking void updates, so each frame will be working on. And when you have a little bit bigger logic, then you have it here, for example, enemy AI, it better not to put the logic that will be if your player will be. It will be take in the other way. So if player is null, will return the function. It means that everything that will be after that won't work. So for example, if your enemy was going to your character and at one moment your character was deleted, it will be just stopped. Nothing will be broken. That's an idea. And then we can go further. So we're taking distance to players. So we should understand to which state should be in our enemy. We're taking vector 3, we're taking our transform, our enemy position, and our player positions. We're comparing them to understand what is difference between them. And as you can see, Unity is taking health of that. So it has a method that just calculates by itself, and you shouldn't think how you should algorithmically better understand it, discover your X, Y, Y, Z. Everything is doing Unity. That's pretty amazing. Then we have distance to player, and if it's less or equals to attack range, it will be attack because it will be the last one. It can be also work with sign, with walking, but attack will be the first one in all this range. Then, if it is more than 2, it will be our side, it will be chase. So we'll be just chasing for that. In our case, it will be just standing. And S1 will be running. So after that, we just have switch case that we have in a lot of other programming languages with break system as it's usually do. So what we have? We have our switch case for current state and which state we'll be using. For state chase, when for example, when for example state chase will be running, and for ideally will be standing. It wasn't right in my case here. Yeah, so if this one is less than sight range, we'll be just chasing for that, we'll be running for that. Otherwise, it will be just ideally, we'll be just standing. So for chasing, we're just taking the same logic that we have been doing here, so just for running to our element, to our player. If attack, we're just taking enemy attacking, and for standing, we're just writing in our debug just that enemy is observing. Why are you doing this way? Because basically here you're writing the logic, how you should attack that, how you should make less your health or any other stuff. So it writes here. Here you should write that. And in our case, we shouldn't do that because it's quite easy basic example, but you'll be able to understand that it works here. In update, in our switch state, current state, so that's how it works. And let's go further. What we have next. So we're going to our enemy. We're just putting this enemy AI here, and we're just checking the box here because it is unchecked in our case, and we're unchecking enemy AI. That was the basic one. Why we should uncheck that? Because it will probably not be working together in this way. So you can just take them two and discover what it will be. But nothing good. So we're running that, and you can see that our cube is going to us, but here will be some changes. You can see we have our console, so it will be going to console. You see our enemy is attacking us. So because it's very close to us. Right now I don't understand why we cannot go further. One sec. Oh, we're just putting down of the plane. So if it will be close to us, it will be stopped and attack will be provided. But we don't have any attack, so it was just saying that. So we see this attack, and how we can, but we don't have any observe, so it will be going here, we'll take him observing. We won't discover anything of that because we haven't been so far, but it will be going so far. For example, right here, I'm just going somewhere long away. You see observing, it just waits when our player will come back to us, and I'm just coming back to us, and you see cube has been going to for us, and then it will be once more time, it will be attacking right now. Yeah, that's how it works. So basically, understand that all the AI that we have is just some algorithms that are being used in our games. Why? To control it, not to have such a big latency, to be able to run it on every computer, on every machine, to control that once more time, and to write a scenario that it's better to game company or the game, the scenario that should be. That's an idea. So we have a lot of others in this case, but I think that even this one will help you to understand how does it work, like to understand the idea of that. So that's all. So thanks everyone for watching this video. Hoping that you're doing good and like this video. If you would like to discover any more stuff in Unity or Unreal Engine or other gaming stuff, game development, please go ahead, write down the comment. I will be really happy to assist you and to have new videos. See you in new videos. Bye.